Hello. In this video, we're going to take a look at special angles as they apply to radians, and also look at complementary angles using radians according to the cast rule. So on the board right now, I have two shapes. I have a square and I have an equilateral triangle. So we're going to use these to kind of figure out our kind of special angle relationships. So if each side of my square is, say, 1, just say 1 of whatever units, then the diagonal here in red, well, it's going to be, according to Pythagorean theorem, root 2. Now, a square has the angles of 90 in every corner, like here, 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 and here. So half of that is going to be 45 degrees. And 45 degrees in radians is actually pi over 4. So pi over 4 is kind of one of our special angles here. And using our trig ratios, we can derive some special angles and what they mean. So if I have, let's say, sine of this angle, so sine of pi over 4, well, it's going to be equal to the opposite over the hypotenuse, so it's going to be equal to 1 over root 2. And if I rationalize it, it's going to be root 2 over 2. Cos of pi over 4, well, it's going to be the same because it's going to be 1 over kind of root 2. So it's going to be the same 1 over root 2. Tan of pi over 4 is going to be the opposite here over the adjacent. So it's just going to be equal to 1. So with pi over 4, we get these kind of very regular, or irregular, values, and they're going to become important as we move forward. Now, on the other side, we have a equilateral triangle. And if each side of my equilateral triangle is kind of 2, 2, 2, and I split it down the middle, I can derive a couple of measurement observations from that as well. So half of 2 here is going to be 1. And using Pythagorean theorem, working backwards, this kind of height of my triangle here is going to be root 3. Now, in an equilateral triangle, all the angles are equal, and all the angles add to 180. 180 divided by 3 is 60 degrees, and 60 degrees is actually pi over 3 in radians. At the top here, this angle, well, it's going to be a little different. It's going to be half of 60, so that's going to be pi over 6, or kind of 30 degrees. So from this, we can actually derive some special angle relationships. So for, divide it up, for sine, and we'll start here with sine pi over 3. So sine pi over 3 is going to be equal to root 3 over 2. For cos, pi over 3 is going to be 1 over 2, or 1 half. And tan of pi over 3 is going to be root 3 over 1. Now, on the other side of this, we're going to take a look at pi over 6. So now we're looking at kind of this angle, so it changes up our opposite and adjacent. So in this case, sine of pi over 6 is going to be 1 over 2. So 1 over 2. Cosine of pi over 6 is going to be our root 3 over 2. It's down. And tan of pi over 6, well, it's going to be 1 over root 3, or kind of root 3 over 3, if we rationalize it. So those are our special angle relationships with sine, cosine, and tangent. And they're going to be kind of useful. So let's take a look at an example. So moving ahead, we have this example. Let's say we have sine pi over 4 multiplied by cosine pi over 4 6 and cosine pi over 3. So going backwards, our special angle relationships, if we take a look at it, pi over 4, well, that's root 2 over 2. So we have root 2 over 2 for this. Same with cosine, it's going to be root 2 over 2 plus sine pi over 6. Well, pi over 6 is 1 over 2. So 1 over 2. And cosine pi over 3 is also 1 over 2. So those are all our special relationship angles. And I can just like kind of plug them in and just do my math right now. So root 2 times root 2, well, that's going to be 2. 2 times 2 is 4. 1 half times 1 half is actually 1 over 4. So 2 plus 1 gives me 3 over 4 as my answer. So actually, these are kind of helpful in that like they can give us very quickly like a definitive answer, especially since we're now using radians. And so like pi radians is equal to 180 degrees. So it just helps us to try and get our minds around this a little easier. So let's look at this involving the cast rule. So if we remember our cast rule, and I'll use a line here. So if we have like a quadrant like this, like so, go back to this, we have our 4 quadrants. So this is quadrant 1, quadrant 2, 3, Roman numerals, and quadrant 4. And our cast rule goes like this. In this quadrant, quadrant 1, all of our trig ratios are positive. In quadrant 2, only the sine ratio is positive. Quadrant 3, the tangent ratio is positive. In quadrant 4, the cosine is positive. And we call it cast rule because it spells out C-A-S-T. So if I have a value and I want to know whether or not it's going to be positive or negative, I just have to kind of look at it and see whether or not it's which quadrant it's in and also which ratio it is. So let's take, for example, tangent 5 pi over 4. So tangent 5 pi over 4, well, it's going to be in quadrant 3. How do I know it's going to be in quadrant 3? Because anything bigger than pi, oops, right here, which is this kind of line here, it's going to be bigger, it's going to be in quadrant 3. So this is actually going to be here. So it's going to be 1 whole pi to here, and then another kind of pi over 4 to here. So it's going to be in our quadrant 3. So it's in quadrant 3, it's the tan ratio, so I know it's going to be kind of positive. Now let's take a look at, say, like cos 3 pi over 4. So 3 pi over 4, well, that's less than 1 pi. So I know, but it's actually more than, say, like pi over 2, or half a pi. So it's more than half a pi, but it's less than 1 pi. So I can figure out it's going to probably be somewhere in quadrant 2. Now in quadrant 2, only the sine ratio is positive. This is the cosine ratio. Therefore, it is going to be negative in that quadrant. And that's how I know. I know it's going to be negative within that quadrant based upon this kind of cast rule. Now, this also leads us to complementary angles. So values for angles are angles where we're going to get like the same value. And we're going to primarily use our special angles for this. So let's go to like another page. Let's set up another kind of quick grid here. So here's my grid, and I want to know kind of the exact value for these various angles or these various ratios. So I'm going to take a look at the first one, and I'm going to say it's, oh, put it here, and I'm going to say sine 5 pi over 4. So taking a look at that, sine 5 pi over 4, we've already established that it's going to be kind of somewhere here. So it's sine 5 pi over 4, so 4 pi over 4 is 1 pi, so that gets us to right here. And then this angle right here is actually just going to be the remainder, which is pi over 4. So pi over 4 is a special angle that we know. Sine pi over 4 is actually sine pi over 4. We know that one. It's actually going to be root 2 over 2. But since it's in the third quadrant, which is the tan quadrant, well, we know this is going to be negative. So therefore, we can say that this sine 5 pi over 4 is actually going to be negative root 2 over 2. So we know it's negative, and we know the value because of the special angle. So we know that pi over 4, which is kind of what is here, is going to be 2 over 2. Well, let's take a look at, say, another one. Let's take a look at, let's say, tan. Let's take a look at tan. I'll do some green. 5 pi over 3. So tan pi over 3, well, that's going to be equal to root 3 over 1. But where's tan 5 pi over 3? So we know kind of what the pi over 3 is going to equal, but we don't know if it's going to be positive or negative. So where is 5 pi over 3? So we know it's bigger than kind of pi. And so then we're going another 2 pi over 3 here. So it's going to be actually in the fourth quadrant. So since it's in the fourth quadrant, which is the kind of cos quadrant, we know that it's going to be equal to negative pi over root 3 over 1. So, because 2 pi over 3 is bigger than kind of pi over 2. So this is 3 pi over 2. It's slightly bigger than that. So we got to kind of figure out where these are relative to each other, kind of based on where it is, and then use our special angles to find out the exact value. You don't even need a calculator for them. Just kind of have to know what these cast rule values are. So let's take a look at another one, the other way. So again, let's do a grid here, and this back. And let's figure out all the values of theta. Like, let's see the values for theta kind of between 0 and our kind of 2 pi, or kind of one time around. Because remember, this is from 0 to 2 pi here, pi over 2, 3 pi over 2, and this is pi. So we're looking for all the values of theta between this. So let's look at, say, cos theta equal to 1, negative 1 over root 2. So right off the bat, I recognize that that's one of my special angles, and I know that cos pi over 4 is equal to positive 1 over root 2. But because it's negative, I know the two angles, or two thetas I'm looking for, have to be in the two quadrants where cos is negative. So it's not going to be in quadrant 4, and it's not going to be in quadrant 1. They're both going to be here in quadrant 2 and quadrant 3. So what are those values of theta? So we know we're looking for thetas where we get pi over 4 kind of in here. So we know that the value here, making this kind of triangle, has to be pi over 4. But what is the value here of theta? Well, the value of theta for these guys, for the first one, so the first theta, it's going to be pi, so one time around, going from here all the way to here, but then we're going to subtract the pi over 4. Subtract pi over 4. So that's going to be equal to 4 pi over 4, because we need a common denominator, minus pi over 4, and that gives us 3 pi over 4. And that's our first theta value for this. So cosine 3 pi over 4 gives us our negative 1 over root 2. But then we also have a second one. We have a second one where we go all the way to this point, but then we go the extra pi over 4. So that's our second value of theta. Our second value of theta, theta 2, is equal to pi, but this time we're going to add pi over 4, because that gives us our other value right here in the third quadrant. So pi minus pi over 4 is in the second quadrant, pi plus pi over 4 is in the third quadrant, and when I do all my calculations, common denominators, I get 5 pi over 4 as my second value for theta. All right, let's try one more. We'll try one more. Let's take a look at this again. And let's do sine. Let's just do this. Sine theta is equal to negative root 3 over 2. So again, this is negative, but now it's sine, so we got to look for the answers in the two quadrants where sine is negative, so that's going to be quadrant 3 and quadrant 4. Now root 3 over 2 is also another one of our special angles. So we know that sine of pi over 3 is going to be equal to root 3 over 2. So this is our special angle, so that's going to come in handy in a second. So we know, because as a sine ratio, that this angle here is going to be pi over 3, special angle, and this angle here is going to be pi over 3. But we need the kind of full angle. So the first one we're going to do, let's do the one all the way to here, this kind of theta. I'm going to call it theta 1. So we know we're going all the way to here, which is pi, and then we're just going to add the extra little pi over 3. So pi plus pi over 3. So I got 3 pi over 3 plus pi over 3. So that gives me 4 pi over 3. So that's my first angle. Now the second angle, I'm going to draw it in green. I'm going to go all the way across or all the way around, and then I'm going to back up another kind of pi over 3. So going all the way around is 2 pi. So in this case, the second one is going to be 2 pi. This minus pi over 3. So 2 pi is going to be 6 pi over 3 minus 1 pi over 3, and that gives me 5 pi over 3. So those are my two answers, 4 pi over 3 and 5 pi over 3. So here's a really important thing to remember, and I'll do another real quick right here, like this. We're gonna, whatever's here, this is going to be kind of what we call theta. If it is in this quadrant here, it's going to be pi minus kind of this angle. If it's in this quadrant here, it's going to be pi plus the angle. And if it's in the fourth quadrant, it's going to be 2 pi minus whatever the angle is. So we got to kind of figure it out from there. So we try to find our special angle, whatever it is. It's in the second quadrant, subtract it. Third quadrant, add it. Fourth quadrant, 2 pi, subtract that. Hope this video helps.